Okay, everyone, since it is 2:01 and we want to be respectful of everybody's day, everyone's time, we'll go ahead and get started. Thank you so much for joining us for this MEng welcome webinar for the class of 2026 for the 1-year, 2-semester long MEng program in partnership with the Fung Institute of Engineering Leadership and the Department of Nuclear Engineering. And I've teed up our department chair, Max Bertoni, nicely for that. Max, I'm going to turn it over to you for welcome and any comments that you might have and any of the slides that you want me to take us through. Just let me know when you want me to advance.
Okay, thank you. I don't know, you're breaking up. I don't know if it was my connection or your connection, but so let me know if there is an issue with the connection. So welcome everyone. As Amanda mentioned, I'm the chair of the nuclear engineering department here at UC Berkeley, and I'm glad to welcome all of you to this info session for the Master of Engineering program. And in addition to myself, Professor Peter Hosman is actually the faculty that is fully dedicated to the MEng program in our department. Is our MEng lead, but unfortunately today he couldn't participate in these sessions. But it will definitely be the faculty you're going to be probably interacting the most as you go through the program. And I'm assuming you already aware of what the Master of Engineering is, but just a reminder for everyone, the Master of Engineering is this professional program. It's quite intense. Basically lasts only 9 months, full time, and you get to combine technical skills as well as leadership skills. So it's quite a unique program. So it's been going now for almost a decade. I think it's been very successful at large as well as for our department. So Amanda, if you want to advance the slide, I'll go through describe a little bit about our department. So I guess you can just go through an entire iteration here. We don't need the animations. Just to say that our department has a long history in nuclear science and in nuclear engineering. Berkeley in general is the place where, let's say, nuclear science and nuclear engineering was basically born. By now, probably everybody has seen or heard of the movie Oppenheimer. He was a little professor in the physics department in the 20s and 30s here at UC Berkeley, or at the same time with many prominent figures in the nuclear physics area like Lawrence and Segre. And you might have heard about Lawrence, and he established 2 national labs that we still benefit today at the UC Berkeley because it's in proximity of those labs. One is the Lawrence Berkeley National Lab, just up the hill from our campus, and the other one is the Lawrence Livermore National Lab that is 40 miles east of here. And I think we also pride ourselves to be probably the only university at this point that has element named after berkelium, together with the other dozens of elements that we discovered right here. So I think today we inherited the legacy history of Berkeley in nuclear science and engineering. With our department was established in 1958 by Glenn Seaborg. If you're going to go next. This is our current faculty. There's been quite a bit of change in our faculty recently. So yes, we have a very young and dynamic faculty at this point that covers multiple areas. Nuclear science and engineering is a quite broad field. And it goes from energy application to science application, national security, medical applications. and so on. You can read about our faculty on our website if you're curious to see what they do. Just very briefly, Rebecca Brigel is mostly the nuclear chemistry area as a medical application. Professor Bernstein and nuclear physics and data. Myself are mostly in the area of energy and reactor design. Professor Goldblum is mostly the area of non-proliferation and nuclear security, radiation detection. Professor Hosman is expert in nuclear materials. Professor Norman in radiation detection. Pearl Peterson, thermohydraulics, reactor safety. Professor Scarlett is also our head undergraduate advisor as thermohydraulics, materials, chemistry for nuclear system. Professor Karshaw is a scientist at the Lawrence Berkeley National Lab, and I mentioned they're very close, so we also have very tight connection with them. And so he has a position both at the lab and with us as an adjunct professor, as an expert in accelerators systems. Professor Sisman is one of the new entry in our department and has expertise in applied reactor physics, experimental reactor physics. Yango Seo is another expression of that broad collaborations that our department has. He's actually a professor at UCSF, University of California, San Francisco, in the radiation oncology department. And he also teaches and advises students in our department in the area of medical physics, so radiation applications in the medical field. Guan Yu Su also joined our faculty only a couple of years ago in the thermohydraulics experimental area. Professor Carolyn Bieber is more on the physics, fundamental physics, dark matter discovery area. Professor Kaiwetter is very active in the radiation detection field. Professor Vujicic also in the non-proliferation as well as numerical methods for reactor applications. And Professor Ali Taman is the latest entry in our department, has been with us only one semester, right? Well, I guess this is her second semester. And she's in the area of fusion. And if you can go next. Yes, this is a summary of the people that Bachelor of Engineering students mostly will interface. In addition to myself and Amanda, right here, I mentioned Professor Peter Hosman is the lead for the MEng program. Professor Goldblum is the head graduate advisor, so since MEng is part of the graduate program, also that might be the person you interface with, and Christina is part of our front office. This is a sort of very rough summary of the areas that our department cover. Many of us do many different things, so it's sort of difficult to catch in a couple of minutes what our department does. Trying to sort of identify a few pillars here. Definitely nuclear energy is one of the main area in the department. Advanced reactors has been a strength for our department for a very long time. Being in California, a place where nuclear energy right now doesn't play a very important role. We have historically focused on advanced reactors and the future of nuclear energy. And of course, we always take a Berkeley spin, I like to say, on things. So not only energy, but energy with focus attention to the impact on the environment. So nuclear waste, the nuclear fuel cycle. Nuclear reactions and radiations. It's one of the fundamental area in nuclear science and engineering. And our department benefits quite a bit from interactions from national labs that are close by. Like makes let's say powerhouse in this area. Nuclear security and policy. Many of our faculty have worked in this area. We have been supported for now 15 years, and we hope for longer by the National Nuclear Security Administration, NSA, to produce novel work and produce a pipeline of people that specialize in nuclear security and policy, and eventually go to work in national labs or government organizations in this area. Nuclear materials, nuclear chemistry are fundamental for any area of nuclear science and engineering, fundamental for reactors, for fusion reactors, but also for radiation detection, security. So it's very cross-cutting, multidisciplinary area. And we have multiple faculty like Professor Hosu and Professor Scarlett as well. So they work in this area. And then it's sort of a new entry for us. This is something more recent. I mentioned our collaboration with UCSF, UC San Francisco, and the Radiation Oncology Department. We have established a new medical physics program. This is CAMPEP accredited. Might not mean anything to you, but that means that if you go through this program, you're basically eligible for residency once you have completed this program, and it's quite a unique feature. If you want to go next, Amanda, and I think I already basically mentioned this. We're fortunate to have many things around us, many national labs. Lawrence Berkeley National Lab, Lawrence Livermore. Right next to Lawrence Livermore is also Sandia National Lab. Sandia has a couple of locations. One of them is here in California. And then there is a national lab down in the Bay, close to that other university of not so much importance. The lab is called SLAC. Yeah, just kidding. The other university is obviously Stanford. And the next slide. And of course, we're also very fortunate to be in the Silicon Valley or very close to the Silicon Valley. So we get a lot of that influence of the mindset of the Silicon Valley with companies, entrepreneurship, and startups, and also startups in nuclear. Right? These are some of the startups in the area directly connected to nuclear. Gamma Reality, it's a radiation detection startup. Actually started from our department. Hopo Therapeutics is also from our department, looking at radioisotope cleanup, Kairos Power Energy. And then there is companies in fusion, waste. So there is quite a bit of happening in that regard, and definitely Berkeley is an environment that stimulates innovation, stimulates entrepreneurship. There are multiple incubators if someone is so inclined as interested to do this. And in particular, the MEng program is kind of interesting because the MEng program is again focused on technical as well as leadership, not exactly on entrepreneurship, but it comes out that many of the capstone projects that the department that the MEng have proposed ended up becoming companies. So that's sort of a side effect of mixing these two skills. And next one. And I guess that's about it. An introduction about our department. I don't know if there is any question or anything I can answer. Otherwise,
I have a question.
Yes, go ahead.
Can you hear me okay?
Yeah.
I was wondering, even though it's not finalized, if we have a draft of what the spring courses might be.
That's coming on an upcoming slide.
The spring, not the fall?
Yeah, I've already looked at the fall online. I think that's more than a draft at this point.
Okay.
Yeah.
Yeah, I have a slide to show what we're currently offering right now, spring 2025. That be a bit of a template or a model for what we potentially are going to be offering in spring 2026. It's not a guarantee because we haven't gone through that phase of the planning process, but it will at least give you an idea.
Can you hear me?
Yep.
Okay, awesome. Can we talk about capstone matching a little bit? Unless that's going to be talked about later.
Yeah.
I believe, yes, I think we have more slides talking about how the program is structured. So maybe we should go to, it seems you guys are more interested in that aspect. So maybe we should go through that and then, we can revisit questions.
Yeah, we have several slides that kind of go through the whole structure. So let me advance the slide deck and we'll probably get to a lot of those questions.
Okay, awesome. Thank you.
Okay, so this is how the program works. It's in our department, but it's very similar in all departments for the MEng program. So you are required to complete 25 coursework units. 8 units are the part of the leadership curriculum, and that's completely administered by the FANG Institute. So those are the classes that you take before the fall or in the break between fall and spring. Within our department, you have to take 12 credits of graduate classes. That's more or less 4 classes because typically our classes are 3 units. And even if you had a class of 4 units, then it still ended up being 4 classes. So usually students take 2 classes in the spring and 2 classes in the fall, then 2 classes in the spring, but it's up to you. And then there's the capstone project. Those are 5 units, 2 units in the fall and 3 units in the spring. What is probably slightly different and differentiate the departments is the way the comprehensive exam is administered. So there is a comprehensive exam everybody has to go through. There's 2 components. One is the leadership component, and once again, this is administered by the FANG Institute. They take care of everything. So any question you have about that, you should ask the FANG Institute, but I'm sure they're already providing quite of information. And then there is one more on the technical area, and that's every department has its own comprehensive exam that is slightly different. In our case, the exam is a written exam, and we want to test that you have some basic understanding of fundamental areas in nuclear science and engineering. So some basic understanding of nuclear energy, a basic understanding of interaction of radiations with matter and materials. So we have a handbook that describes all of this. I don't know, Amanda, if you already shared that or we're gonna share this soon, and you'll find all the information there. But it's a written exam. And now, if you have already a background in nuclear engineering, you already got a degree in nuclear engineering, maybe your undergrad was in nuclear engineering, or you have taken classes in nuclear engineering, that's probably going to be straightforward. So we have reading associated that we suggest. I guess you can just pick up the book and read through the book and refresh this concept, and you should be fine. If you never had classes in nuclear engineering, if your degree was in something different, so you have no exposure so far, we recommend taking a 200 M introduction to nuclear energy and technology. So that will help with the comprehensive exam. Next. Okay, and I guess this is, I don't know, Amanda, I should let you talk over this. You're probably more familiar than me with this.
Sure. So this is actually what our fall 2025 academic schedule looks like. Specifically, I tracked it out. Any classes that have an M designation, which is mezzanine level, which is particular are pertinent for all of our Masters of Engineering students. Those are the classes that you should sort of be identifying and enrolling in, because they are kind of specifically kind of customized and tailored for an ed student. So as I mentioned, there's
Amanda, your sound is, I don't know if it's only me, but your sound is quite noisy.
quite see. Okay, sometimes when buses go by,
No, it's breaking up. It's coming and going. It's unstable. I don't know.
Okay, Max, maybe you should take over then.
Okay, right now you are fine. I don't know if there was something that has changed. Okay. Anyhow, this is the list of classes. Again, the requirements is you have to take graduate classes. So anything that has a 200 that starts with a 2 is the classes that that you want to take. When there is an M, this is basically classes that have sort of been designed for the Master of Engineering program. That's what we call mezzanine classes. And again, it's mostly dedicated to students that might be, for example, if take 210M is our nuclear reactions and radiation class. If you never take any class in this area, this is a good class with you to take if you want to specialize in that area. Usually these classes are what we call room share with lower upper division undergraduate class. So you'll be basically in the same with 101, and that's the equivalent class to this. This is the list of class. If there is a C in front of the class, it means that the class has a sort of a code share with another department. For you, doesn't really change anything as long as there is any in front of it. You are good. And just if you want to stay a second on that. This 295 class, this is a nuclear engineering colloquium. That's a 1-hour seminar that we have every week where we invite experts from all over the country, potentially abroad, to discuss the latest, the hottest, the most interesting in the different areas of nuclear science and engineering. So the topic is different every week. As you can see, this is 0 units, so it's not going to count towards your requirements, but and there is no exam, nothing to do associated with it. It's just show up and listen, and I highly recommend it. So even if it's 0 units, I think it's a very good value if you're interested in this area to see what is happening, what is the latest in nuclear science and engineering, and what people are working on. And I guess this is the tentative spring class. So I'm not sure actually we're going to offer 201 since we're offering again this year, already this year. But so for the classes like 215M, that's going to happen for sure. So usually the M classes are offered every year. So you very likely can count, if there is an M at the end of the number, you can assume that the class is going to be offered, I would say 100%. So 215M is going to be offered for sure. That for next year. So this is the plan right now. This nuclear reactions and interactions, radiation with matter at 201. I suggest you take this only if you already taken a nuclear physics class, or if you take 210M. So you should take 210M the first semester, and then this one if you're interested. Similar for 220. If you already had something in this field, that's fine. But if not, I would recommend to take 120 first. I don't remember what is the equivalent M class. And no, I think that's. I don't know if there's anything else to add. And I guess you've already said this. So 12 units. Potentially, you could do with 3 classes if you take 3 4 units classes. Otherwise, 4 classes of 3 units. And 295, 298, 299, 375, those classes do not count towards those 12 units. I mentioned already the colloquium 295. As we already mentioned, and you probably already know, in order to complete the requirement and to complete the technical part of the curriculum, you need to work through a capstone project. This is a group project. Group goes through 3 to 5 students, depending on the projects, and you work through a project over 2 semesters. The Funk Institute is going to guide the structure of the projects, the reports, and the timeline. And you're going to work with a faculty advisor or an industry advisor on the project. So typically 2 units in the fall, 3 units in the spring. That means in the fall, you're probably going to spend 6 to 8 hours a week working on the project, and then you ramp it up to 9, 12 hours a week in the spring semester. And at the end of the day, you're going to get a grade like any other class. And I don't know if there's an additional slides, I assume. Oh, comprehensive exam. I think I already mentioned about this. As a 90 minutes written exam with some questions about basic concepts in nuclear science and engineering. This is the book that we recommend. It's once you have a Berkeley account, it's available electronically at the library, so you don't have to buy the book or anything. If you want to, you can buy it. If you want a physical copy, but you can access an electronic copy, so you can go through and see what is. So the level of what is expected, again, the level is, I think, is quite basic. And I think this is things actually already said. Take 200 M if you're never taking any nuclear engineering. Otherwise, just read through the book. I think it's an easy read. The exam is usually offered in the December-January timeframe. And in case you don't pass, you get a chance to repeat it sometime in March, typically. So we have a few concentration. This is rough concentrations. Like if you're trying to plan for classes and areas in which you want to specialize or focus, we have this 4 concentration: nuclear reactor design, management, infrastructure, applied nuclear science, radiation detection, nuclear materials and manufacturing, medical physics. Nothing is set in stone. You are free to mix and match classes as you like. This is just sort of guidelines if you're interested in one of these 4 fields, but you build your own program as you like. Next, there's this, again, just classes that are mapped to the topical areas, to the concentrations. Again, just recommendations. You can mix and match classes as you like. So the capstone project, how does it work? Well, sometime in August, you'll get a list of capstones. It's a very long list. I don't know, I think right now it's probably gets to 200 or more project. And this, what these capstones are, is to get a description and a video. These days they want a video. I don't know if they're still doing that, but potentially faculty or industry sponsors provide a description of a project they have in mind and they would like to propose. And together with that, faculty or industry indicate what are the skills that are needed, and what disciplines across the college can apply for that capstone. So also usually we have office hours, so in that scoping phase, you see the description of the capstone, and also every faculty usually gets an hour and 30 minutes at Zoom, virtual office hours, when they can actually further discuss the project, or if you have any question for the faculty, they can, or the industry mentor, they can answer those questions. Once that happens, you send, once you have seen the list, the application period opens. So basically what you do is like when you're applying for a job, more or less, you go in and says, I'm interested in this project. I'm a good fit because this and this. You submit your information. The process kind of changes a little bit every year. And Peter has been managing this in the last few years. So I don't know exactly what is the latest. In the past, you submit your CV and do all of that. And usually you rank also your projects, and this is my first priority, second priority, and so on. So after you have applied, the faculty comes back in, looks at the applications, and they might offer you the job or not offer you the job for the capstone. And so you might get your first choice, or maybe you're not going to get your first choice. Depends on the faculty, the industry, the industry sponsor. Now, technically, you can take your capstone in any department, so it doesn't have to be a capstone in nuclear engineering. But if you take a capstone that is not sponsored by nuclear engineering, then you have to vet that capstone with the MH lead, so Professor Hosman. You might want to send an email to Professor Hosman and says, I want to take my capstone in I don't know, mechanical engineering or computer science or whatever it is, and we still expect that there is some relevance to nuclear science and engineering. If you want to take a capstone in high frequency trading in computer science, that's probably not relevant to nuclear engineering, so we will probably not accept that. Or if you're taking capstone on materials, high temperatures in the material science department, then that's probably relevant. Or you're taking a capstone turbines, mechanical engineering, whatever that could be, then we see that's still relevant. And I don't know if there was okay, I guess this is an example of projects that we had in the past. Tend to be again a widespread reactors, different systems. And I guess this is if you go next, this is, as I mentioned, also industry can sponsor projects, and this is some of the industry that sponsor projects. I know this is a different slide. Okay. Before we go to the slide, let's stay there for a second. Industry can also sponsor project. We had some industry sponsoring project in the past. X Fusion is a fusion company that's regularly sponsoring capstone projects for the last couple of years, and other companies have done in the past. I guess we still don't have a full picture for what's happening. In next year, we have been talking with some company like fusion company like Alpha Ring that they might be sponsoring some of this project. And I guess this actually was a picture of what students do after master program, after master engineering programs. short list, a very short list of companies that students have gone through. Some students really enjoy the research part, and so they decide that maybe they want to continue for a PhD, so they go on with PhD. Most likely not in Berkeley, elsewhere. It also can happen. There's maybe one or two people that every year join our PhD program. I think there is a good number actually goes to PhD somewhere else. Many go directly to work for industry. Kairos is also here in the Bay Area. It's been a good employer of Master of Engineering, and there are other. Actually, Xfusion that I just mentioned, I hired one of our Master of Engineering student, and the student came back, and obviously like the format of the program, and is sponsoring a capstone project. Tri-Alpha Energy also has been another company we've been collaborating with, also through another alum of our Master of Engineering. And I think there was this last slide. So of course, very important to us that everybody feels welcome in our department. We have a relatively small department. We enjoy and we are proud. We take pride of that small community that we are. But even in a small community, we want to make sure that everybody feels welcome. So it is very important that reciprocal respect of faculty, staff, students of any background and of any opinion should be respected and valued. Okay, I guess we can go back to the question. And I see Catherine had a question: what is the opportunity to work with startup companies for our capstone? As I mentioned, there definitely might be opportunities. They're not the same every year. So the period to submit capstone project for next year is already started, but usually most capstone projects come in during the summer when everybody as a moment can take a moment to think about what are the projects. So we will have a better picture during the summer, but potentially there is definitely that potential. Which company we will know probably better during the summer. And Nick, I know you had a question about the capstone. I don't know if I answered that question. I guess you had a question about matching, if I understood correctly.
Yes. Yes, you answered it. Thank you.
Okay.
Another question though. So if there's a company that you would like to work at that's not sponsoring any of the capstone projects, is there any way that we can get FaceTime with them somehow? Or, I mean, if they don't have job openings, they don't have job openings, but I don't know. Is there any way we can get like extra time with them?
I'm not sure. I mean, if they're not supporting a capstone, I guess I'm not understanding exactly the question. How will you be connected to a company that is not participating in the capstone? Are you asking if you're not in that capstone, if you can still be connected to that company?
Yes.
Yeah, that's always an option. Absolutely.
Got it. Okay. Thank you.
I have a question.
Yes.
Looking through the course catalog, and does Nuke 200M equivalent to Nuclear 101?
No.
Okay.
210M is equivalent to 101.
Gotcha. Thank you.
I have a question.
Yeah.
I was wondering, for those of us that pursue this, if there's actually like an easy way of connecting with the nuclear specific alumni of the MEng program.
Before or after?
Well, after probably, but you know, just as you know, one nears the end of the program and you're in the job search, just knowing, hey, there's some people that did the same program that are at these companies that maybe I could talk to and gain some insight. And you know, the people that would be most likely to go to the nuclear startups and things would be the MEng alumni.
Yeah, that's a possibility. Some of those alumni definitely like also stay local, so that's an option. Actually, some time ago, we had started creating a LinkedIn group for our MEng alumni. Maybe this is something we could reevaluate. Yeah, that's correct. Definitely Bank Institute organize those kind of events. Yes.
I have another question.
Yeah.
How much lab work is involved in each of the new courses? Just curious.
Mostly, I would say it depends on the curve, on the class. Most have limited. Most of these classes that we see here, they have a limited lab exposure.
That makes sense. Thank you.
Like 201 that is not here might have some component. 220 might have some component. But most of these have limited actual lab experience. Yeah. Now, depending on the capstone that you choose, if you were interested more like in hands-on type of work, some capstones definitely are more hands-on, some are more theoretical. Like, you know, if you have a capstone with Professor Husman, very likely you will have lab experience. If you do a capstone with me, you're going to be working on a computer and modeling and simulation. So.
Thank you.
Will these slides be emailed out to the group?
Okay. And actually, all the information that are on these slides are more extensively provided in the handbook. So I would recommend actually you, rather than the slides, you read through the handbook. That would be more comprehensive. And Amanda, we said we already sent it, or we're gonna send it out?
So I haven't given these folks access yet.
Okay.
Usually I save that for people who have berkeley.edu email addresses who've already.
Yes. Okay. So once once you are in the program, you'll have all this information, extensive information. Any other question? Anything I can help with?
I guess one last one. So you mentioned our technical concentration as not strong bearing on the classes that we have to take, right?
Yeah, again, if you want to go back to the table on the next next one. Yeah. So for example, if you're interested in energy and reactors, this is the classes that we would recommend. But you don't have, there's no enforcement of that. There's just guidelines. You know, if you're interested in medical physics, this is the classes we would recommend. But again, you don't have to take, or you don't have to stick with this list. If you want to take three from this list, then one from another list, it's perfectly fine. And also, as you can see, there is a lot of overlap between different lists.
Thank you. That's excellent.
Well, if you have any other question, we are here. And if you don't have any imminent question, you know, we hang up and say, "Oh, I forgot to ask that," or tomorrow, if you have any other question, please feel free to reach out. Amanda will be probably the most responsive of everyone, and she will know how to connect, and she'll make sure to get you an answer